Hello students, in the previous video we discussed about what is organic chemistry and what is the importance of carbon in all their daily life, and in this video let us focus on the classification of organic compounds. The study of carbon compounds is called as organic chemistry. So definitely we have many compounds are there. So if many compounds are there, definitely we need to classify them, yes or no? So in this video let us focus on how organic compounds are classified. But to discuss about that, first of all we need to know that organic compounds are mainly made up of carbon and hydrogen only. Remember, organic compounds are made up of mainly carbon as well as hydrogen. So what is the valency of carbon, students? Valency of carbon is 4. That means it can form 4 single bonds. So accordingly you should assign the number of hydrogens. So why I am saying this? Because in the organic chemistry discussion there are many compounds are there. Every time no need to write the whole formula. For example, C2H6. What is this compound name? Ethane, yes or no? So instead of writing the whole compound, we can directly mention like this. For example, C3H8. How many compounds are there? How many carbons are there? 3 carbons are there. If you want to write completely, you should write like this. By satisfying the valency of carbon, we should represent the molecule like this. But no need to represent all the hydrogens. You can simply represent the carbons. That's it. That means carbon, carbon, carbon. This represents the same C3H8 molecule. In the whole organic chemistry, we deal the organic compounds with these representations only. These representations are called as skeleton formulas. Skeleton representation is the point clear. So how can we get this formula from this? Means the same. What is the valence of carbon? The valence of carbon is 4. Here for carbon, how many bonds are there? 1 bond. Remaining how many bonds are there? Remaining 3, right? So 3 hydrogens. For this middle carbon, how many bonds are there? 2 bonds. So more how many hydrogens? 2 hydrogens. For the last carbon, how many bonds are there? Only 1 bond. So more how many hydrogens? 3 hydrogens. We got the previous representation or not? Like that. So we don't represent in general, not this way. We simply represented only the shortcut, only the carbon skeleton. Remember that. What is carbon's electronic configuration? 1s2, 2s2, 2p2. This configuration is called as ground state configuration. Remember, whenever if I ask to write the configuration, whenever you study about organic compounds, remember you have to mention only excited configuration. Excited state configuration means you already know S contains 1 orbital, P contains 3 orbitals, right? So here 2 electrons are there, here only in the p subshell 2 electrons only there. So this electron excites into this empty orbital during the bond formation. So what is the new representation? Here now 1 electron is there. In these 3 orbitals now how many electrons are there? 3 electrons. That's how the valence of carbon is 4. This configuration is called as excited state configuration. By subshells we can say like this. 2s1. Here how many electrons are there? 3. 2p3. So every time, students, remember, where following according to the Aufbau principle is okay, but when we are talking about organic compounds and their bonding, so we have to consider the excited state configuration only. From next time you have to say this configuration. What is the configuration of carbon? 2s1, 2p3. So students, you can see in this configuration how many unpaired electrons are there. You can see 1, 2, 3, 4. Yes or no? 4 unpaired electrons are there. What is octet rule? Every element try to get 8 electrons in its valence shell. Yes or no? So here how many electrons are there, students? Only 4. More how many electrons it needs? 4. Does it loses 4 electrons? We discussed in the previous video also. No. Carbon, can it gain 4 electrons? No. It doesn't have that much of electronegativity to gain electrons, and it doesn't have that much of electropositivity to lose electrons. So what carbon does is carbon shares its all 4 electrons. All 4 electrons shares with other elements, whether hydrogen or oxygen, depends, and it can form 4 single bonds. Not only single bonds, students, carbon can form double bonds and triple bonds also. You have to remember carbon valence is 4. So you can see in these examples, what is this? Carbon single bond. Of course, remaining bonds with hydrogen that you already know. Yes or no? I didn't mention any hydrogens. Here carbon forms how many bonds? Between carbon, it can form double bonds, and between carbon, here it is triple bond. So organic compounds are mainly, students, called as alkanes, alkenes, alkynes. Single bonded compounds are called as alkanes, double bonded compounds are called as alkenes, and triple bonded compounds are called as alkynes. We have one more category. The single bonded organic compounds, the single bonded carbon compounds are called as saturated hydrocarbons. Saturated hydrocarbons. And these double bonded and triple bonded organic compounds are called as unsaturated hydrocarbons. Unsaturated hydrocarbons. This point also you have to remember. So why these are called as saturated, why that is called as unsaturated? For students, for example, have you heard about saturated solution? What is saturated solution? Saturated solution means if we cannot add more solute into that, that is called as saturated solution. Yes or no? Similarly students, here in this organic compound, single bond is there, remaining 3 bonds are with hydrogens. Yes or no? Can we add more hydrogens to this compound? Can we add more hydrogens to this compound? Means the answer is absolutely no. But look at here, already double bond is there. How many bonds are there? More 2 bonds with 2 hydrogens. Or no? Is it possible to add more hydrogens to this? Yes, it is possible. How? By breaking this pi bond, we can add more 2 hydrogens. Now the valence is 4 only. Yes or no? Is it possible to add hydrogens? Yes, it is possible by breaking these 2 bonds. So that's why students, alkanes are called as saturated. Why? Because we cannot add more hydrogens to that. Why? Because already 3 there, ultimately it is saturated. We cannot break the sigma bond. Remember, pi bond only. And double bonds and triple bonds, they have pi bonds. We can break that pi bond and we can add more hydrogen. That's why they are called as unsaturated. More can be formed. More we can add. More hydrogens can be added. On that logic, they are called as saturated hydrocarbons, and double and triple bonded compounds are called as unsaturated hydrocarbons. Got the clarity? So students, mainly organic compounds, they're mainly classified into open chain compounds and closed chain compounds, and the classification is not so typical. Very simple in the name itself. Open chain compounds are aliphatic compounds, means oil forming compounds. So what are open chain compounds? Simple. How organic compounds will form? How carbon forms bonding? Carbon bonds with another carbon, it bonds with another carbon. Yes or no? This is organic compound, right? Carbon bonds with n number of carbons. N number, it can be one carbon compound is there, 2 carbon compound is there, 100, infinite number of carbon linkage is there. Yes or no? So open chain compound means carbon bonds to carbon to any extent, but terminal carbons, they do not combine. Terminal compounds, they do not form any bonds. Simple open chain structure, that is called as open chain organic compound. Then what is closed? Closed compound means, students, carbon bonds with carbon, it bonds with carbon, if it bonds with another carbon, if completely, look at here, look at their arrangement, they're completely arranged in a cyclic manner or not. These compounds are called as cyclic compounds, are closed chain compounds. There is one more name called as ring chain compounds. Why? Because terminal carbons are attached. They are like a completely cyclic arrangement. You cannot identify a beginning and an end. It's a cyclic structure. So these compounds are called as closed chain compounds or cyclic compounds. Mainly, this is the main classification of organic compounds. And here, open chain compounds are mainly subcategorized into alkanes, alkenes, and alkynes, which you already know, we discussed in the previous step. So alkanes means single bonded compounds, alkenes means double bonded compounds, alkynes means triple bonded compounds. That is all about open chain compounds. Now, closed chain compounds are subcategorized into homocyclic compounds and heterocyclic compounds. Homocyclic and heterocyclic means, students, in the carbon chain, in the carbon ring, only carbons are present. Only carbons, that is called as homocyclic. Then what is heterocyclic? In heterocyclic compounds, so in the cyclic ring, there is an element other than carbon also present. Sir, which element? It can be oxygen, it can be nitrogen, might be included in the cyclic ring. That compounds where in the cyclic ring there are elements other than carbon are called as heterocyclic. If only carbon, homocyclic. And they are subcategorized into alicyclic, aromatic. So first of all, I'll explain what is aromatic in a brief way. Aromatic compounds means mainly they contains delocalized pi electrons. That means, simply remember, alternate single bonds and double bonds are there, and the compound should be a planar structure. More about these aromatic compounds we'll discuss by the end of this chapter. We have a separate discussion altogether. You should identify the difference between alicyclic and aromatic. Alicyclic compound, are there any alternate single and double bonds? So, alicyclic, and all are carbons in the ring, so comes under homocyclic compound. This is aromatic compound, alternate single and double bonds, but all are carbons only, right, in the cyclic ring, so called as homocyclic. And look at heterocyclic compounds, same definition for alicyclic and aromatic. But here, students, here you can see in the cyclic ring there are elements of carbon as well as there is other element also, which is oxygen. Yes or no? And of course there are no alternate single and double bonds. So alicyclic, heterocyclic. And look at these aromatic compounds. In this aromatic compound, which comes under heterocyclic, there are other elements also, there is other element also which is nitrogen present in the cyclic ring, and it should have, and it has aromaticity, alternate single and double bonds. So this is mainly the classification of organic compounds, and based on this classification only we have all the discussion of alkanes, alkenes, alkynes, cyclic compounds, alicyclic compounds, aromatic compounds, everything in this chapter. So that's all for today in this video. Next video we'll focus on the next part of the organic chemistry. I hope you understood. Thank you very much. Thank you, students.